Over the next 10 years, nanotechnology applications might affect nearly every type of manufactured goods. Nevertheless, the promise by nanotechnology of a significant contribution in the quality of life may be outweighed by the perceived environmental and health risks it poses.
Due to insufficient data, it is difficult to assess the risks associated with nanotechnology at industrial settings. SMEs are particularly vulnerable to this due to lack of resources to implement risk remediation methods to safeguard their workers' health and safety.
What are nanomaterials?
The European Commission defines nanomaterials as any material that ranges between 1 and 100 nanometers. A nanometer is a billionth of a meter. So these materials are very, very small. They have very interesting properties and are integrated in a lot of products. The advantages of nanomaterials are numerous due to their small size, which makes them completely different to their bulk counterpart. However, the risks of nanomaterials are not known because of the small size, and they could be harmful to the human and environmental health.
Some nanomaterials can cause adverse effects on human health, such as lung inflammation and the generation of tumors. However, some nanomaterials are toxic, while others are not. Within Europe, thousands of research projects deal with nanomaterials, but only a dozen deal with safety measures at workplace. Workers' health and safety are not the main focus of the research activities, and the scientific community requires more information about the risk exposure. Physico-chemical changes in the properties of nanomaterials, in most cases unforeseeable, can affect the impact they have on a human body or the environment. This creates a health and safety problem that needs to be solved in order to better control the risks linked to these new materials.
SANOWORK is the name of an FP7 funded project under the European Commission, and it stands for Safe Nanoworker Exposure Scenarios. The project looks at 5 different nanomaterials that are used in an industrial setting, and it assesses the exposure to the worker working with these nanomaterials. SANOWORK looks at lowering the harmful effect of nanomaterials that are posed to the worker in terms of lowering the toxicity. This can be done by implementing risk remediation methods, by changing the structure of the nanomaterials while maintaining the functional properties of the nanomaterials.
Concretely, the research and development activities of SANOWORK concentrate on 5 nanomaterials: zirconium dioxide, polyamide, titanium dioxide, silver, and carbon nanotubes. 3 nanostructures: nanoparticles, nanofibers, nanotubes. 6 processing lines in laboratory and on-site. The 6 target processing lines, located in small and large companies in different regions of Europe, manipulate nanomaterials that carry risks for the workers. SANOWORK developed a safe-by-design approach, meaning which modification can be made on a nanomaterial to reduce its toxicity. Examples of use are spray drying to reduce dustiness of nanopowders, purification treatments to reduce toxicity of nanosols, wet milling techniques to reduce aspect ratio of nanomaterials. The research team cooperated intensely with the Nanosafety Cluster, an initiative to share research results between the EU and the US in the field of safety for nanomaterials. Validated standardized methods to quantify air concentration of nanomaterials do not exist yet. No specific screening tests can be proposed for the medical surveillance of workers exposed to nanoparticles. SANOWORK advocates for a common regulatory framework at EU or international level for safety around nanomaterials. The goal is to protect workers, but also consumers and the environment.